In this next chapter, we will take a look at differential calculus and derivatives. So start by recalling the example that we used to introduce the limit. We had a parabola y equal to x squared, and we wanted to find a tangent line to the parabola in the point P, 1, 1. So what we did was approximate the slope. We chose a nearby point Q, and we moved this point closer and closer to the point P on the parabola. And then we computed the slope for PQ. For Q going towards P. So if we want to generalize this, we have some function f. We have the point P on f, so it has coordinates a, f of a. And then we take points Q with coordinates x, f of x, which moves towards P. For this point, we also know that x is not the same as a, because the limit was defined as the points towards the point P, but different from that point. And now we calculate the slope. So the slope of the line segment, the line PQ, we indicated this with m. This is then f of x minus f of a divided by x minus a. And then to find the slope of the tangent line, we took the limit for x going towards a of all those slopes. Therefore, the tangent line to the curve y equal f of x in the point P with coordinates a and f of a is the line through P and with the slope given by the limit formula. So the slope m is the limit f of x minus f of a over x minus a, and then the limit for x towards a. Let's quickly recall the calculation through some examples. So examples. For the first one, you want to calculate the tangent line to y is equal to x squared in the point P, 1, 1. So this is the example we used before. We have seen how to calculate the slope. So we had the slope was the limit of f of x minus f of 1 divided by x minus 1 if x moves towards 1. And we calculated the slope to be 2. Hence, my tangent line then becomes y minus 1 equal to 2 times x minus 1. Or y is equal to 2x minus 1. For the second example, take y equal to the cube root out of x and take the point P, 0, 0. Y is the cube root out of 3 is the same as x to the power 1 over 3. And if we then take a look at the plot, we see that the plot seems to indicate that at the point 0, 0, we have a vertical tangent line. It seems to be that y equals 0, so the y-axis will be the tangent line at the origin. Now let's also calculate this. So we calculate the slope, the limit of f of x, so x to the power 1 over 3, minus f of 0, which is 0, divided by x minus 0, and then we move x towards 0. So this is the limit of x to the power minus 2 over 3 for x going to 0, or a limit of plus infinity. So this limit does not exist, it is plus infinity. Hence, our slope will be plus infinity, and we are indeed confronted with a vertical line in the point 0, 0. The vertical line through 0, 0 is the y-axis. This slope formula often gets also a different notation. So we had m was the limit f of x minus f of a over x minus a, and then the limit x towards a. If we then say that h is x minus a, then we know that if x moves towards a, then h will of course go to 0. And then m, my limit, is the limit for h going to 0 of f of x, but we see that x is equal to h plus a, so a plus h, minus f of a, divided by h. So we obtain an alternative formulation for the slope, and sometimes it is easier to work with this formulation than with the previous one. It will depend a bit on the function. In this formula, h is actually just the distance between x and a. So h is the distance between x and a. Let's now apply this formula. So the question remains the same. Find the tangent line to the function y is x divided by 3 at the point P 3, 1. We will calculate the slope and we will use this new formulation. So the limit for h going to 0 of f of a plus h. So a plus h, in our case, this 3 is a, 1 is f of a. So it is 3 plus h minus f of a, so f of 3, divided by h. Limit for h to 0. We then plug in 3 plus h in the formula, so y is x over 3. We plug in 3 plus h, so it's 3 plus h divided by 3, minus f of 3, which is 1, over h. This becomes, if you put it on the same denominator, 3 plus h minus 3, or just h divided by 3 over h, for h going to 0, or the limit is 1 over 3. Hence, the tangent line will be y minus 1 equal to 1 over 3 times x minus 3. This slope formula, it appears in many domains. So it appears in physics, it appears in chemistry and economics, and they all found basically the same formulation independently from each other. And each time it indicates a rate of change. And so this rate of change was given a special name. It was defined as being the derivative. The definition then becomes the following. So if we have the derivative of a function f, the derivative of a function f at some number a is defined as f prime of a, so we write it as f prime of a equal to the limit f of a plus h minus f of a divided by h for h going towards 0, provided that this limit exists. Or equivalently, it is also the limit for x towards a, f of x minus f of a divided by x minus a. If f prime of a exists, so if f prime a exists, then we call the function f differentiable at the point a. So take the following example. Find the equation of the tangent line. So find the tangent line to the parabola. The parabola with equation y equal to x squared minus 8x plus 9 in the point 3 minus 6. From what we saw before, we know that the derivative is the slope of the tangent line, and so we will first have to calculate the derivative in the point 3 minus 6. So the slope of the tangent line is the derivative. So we have to calculate f prime in the point 3. So f prime is the limit h going to 0, f of 3 plus h minus f of 3 divided by h. We substitute 3 plus h in the formula, so it is the limit h to 0. 3 plus h becomes, or f of 3 plus h becomes 3 plus h squared minus 8 times 3 plus h plus 9 minus f of 3, which we know from here is minus 6. divided by h, and then we work it out, so it becomes the limit h to 0, 9 plus 6h plus h squared minus 24 minus 8h plus 9 plus 6 over h, which is the limit h to 0, h squared minus 2h, and then we have 9 plus 9 plus 6 minus 24 is 0, divided by h. This is the limit of h minus 2 for h going to 0, or it is minus 2. Therefore, my tangent line becomes y minus minus 6, so y plus 6, is equal to minus 2 times x minus 3, or you get y plus 6 is minus 2x plus 6, or y is minus 2x.